Last example, we're going to look at mixture problem, and I'm going to take this example from a chemistry problem, but you'll see several different types of mixture problems throughout this section, including mixing different strength coffees, different types of chocolates, different percent fat milks, lots of different things that you could mix together. And so in this one, this person has access to 12% and 30% iodine solutions. It says how many liters of each of those solutions must be used to produce a total mixture of 90 liters of a 22% iodine solution. So they're taking two solutions, a 12 and a 30, and mixing them together to produce one in the middle, which is the 22%. They need 90 liters of the 22, so the question is how much of each of these do you have to mix to get the desired amount? And so we're going to have to come up with a formula, and the formula is similar to all the other ones we've looked at already. It's some sort of rate times an amount equals a total. And so in our case, if we take the rate, the rate multiplied by the amount of solution, that will give us the amount of iodine. Okay, so if you take the amount of the solution, the 90 liters for instance, multiply it by the rate, which would be 22% or 0.22, you would get the amount of actual iodine in that solution. All right, so that's kind of our basic formula structure. I also need to define my variables. And so I'm going to use x and y as my two variables, and of course the last sentence, well, the whole thing is one sentence, but it says how many liters of each of those solutions do I need? So that's what's unknown. So I'm going to let x be the amount of the 12% solution, and y is going to be the amount of the 30% solution. Okay, so that should give us our two variables. Now, just like before, we're going to set up a table to organize our thoughts here. And the table in this case is going to have three different rows because there's really three solutions at play here: the 12%, the 30%, and the 22%. So we're going to have a row for the 12% solution, a row for the 30%, and a row for the 22% solution. Okay. Now we need a little bit of space here because there's quite a bit of information to put in each of these rows. Okay, now up on top I'm going to use my formula, the rate multiplied by the amount, I'm going to abbreviate here, amount of solution is going to equal the amount of iodine. Okay, so that gives me my table set up. Then the rate for each of these is just the percent converted to a decimal. So 0.12, 0.3, and 0.22. The amount of solution, the variables represent the first two, and the third one we know from the story problem is 90 liters. The amount of iodine is the product going across in each of these cases. So it's 0.12x, 0.3y, and 0.22 times 90. Now that value we could actually calculate. If I do 22 times 9 to start off, that's 18, 19. I need to add a 0 from the 90 and 2 decimal places from the 0.22, so that gives me 19.8. All right, just so I have that value, equals 19.8. All right, so my system then, I got to set up my system. This organized our thoughts. The amount of solution from the first two has to add up to the third. Okay, and so my first equation is just x plus y equals 90, right? The first two amounts have to equal the third. Same thing for the amount of iodine. The iodine from the first two has to equal the iodine from the third. So 0.12x plus 0.3y equals this last one, which is actually 19.8. We calculated that out. So this system of two equations is what I need to solve. Typically, substitution method will work. I'm going to subtract the x from both sides and maybe solve for y, because I think it'll be nice to plug that in here. So let's go y equals 90 minus x. And I'm going to then substitute 90 minus x in for the y in the other equation. So this becomes 0.12x plus 0.3 times that new expression equals 19.8. The new expression is 90 minus x. I'm going to run through this kind of quickly, distributing, because we've seen a lot of this stuff already. Distribute the 0.3. 0.3 times 90, 30% of 90 is 27. So it'd be 27 minus 0.3x equals 19.8. Yep. And then I'm going to combine my like terms. Now 0.12 minus 0.3 is going to be what, 0.18. It's like 30 minus 12, 0.18x plus 27 equals 19.8, but the problem is my bigger one is the negative one, so that should be negative right there. I'm going to then subtract 27 from both sides, and if I do 27.0 minus 19.8 to get my difference here, borrow 16 minus 9 is 7, 10 minus 8 is 2, 7.2. So I get negative 0.18x equals negative 7.2. Divide out the negative 0.18. And x is going to equal whatever that is. Now I think that's going to be 4 or 40, probably 40. But let's divide it out. Again, I'm going to move my decimal twice in the bottom, so I need to move twice in the top. So we're going to have 18 into 720. That moves it twice in both spots. 18 goes into 72 4 times. 4 times 18 is 72. And 18 goes into 0 times. So it is going to be 40 times. Alright, and so that ends up being the amount from the 12% solution. And then to find the amount for the 30% solution, I just need to subtract that off of the 90. So y equals 90 minus 40, which is 50. And so, oh, there you go. 90 minus 40, which is 50. And so my final answer, I'll just write it out on the bottom here, is, let's see, we need 40 liters of 8% solution and 50 liters of, oh, it wasn't 8%, I'm sorry, that was 12%. 12% solution and 50 liters of the 30% solution. 30%. Alright, sorry that got a little bit crammed at the bottom, but that will work.